Hello, everyone. Thank you for joining us for episode 3 of our Intelligent Apps with Serverless on Azure series, Azure Container Apps Uncovered. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and stay on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. The session is recorded and will be available to view on demand in 24 to 48 hours. With that, I'll turn it over to our presenter. Stas, thank you so much for joining us.
Thank you for inviting me and welcome everyone. So today I will be talking about Azure Container Apps and scenarios, workloads, and portability of Azure Container Apps. And I will be sharing some personal experience and some takeaways about using them in production or switching to the container apps in production. So today's plan is introduction, container apps basics, then distributed application runtime role in container apps and its role in the portability of your applications. Then it's usage scenarios and also portability scenarios, and then it will be demo and questions. But I would encourage you to ask questions during the talk. And I will switch to, and I will be switching to the demo constantly between slides to show the real configuration, real things. With that being said, my name is Stas, in full Stanislav. I'm a Microsoft Azure MVP working as a cloud architect and Solidify IB, and I've been in tech for maybe 20 years and switched many positions from management back to the technical stack and etc. I'm running Microsoft.NET user group Odessa, Ukraine, and also active mentor at Atomspace and IT to School community. It's essentially a branch of Code Club in Ukraine. So with this introduction step is passed, what about serverless containers? It's a generic introduction, but it's important to understand the basics. So there is a serverless functions across any cloud, and there is a serverless containers also. What makes containers serverless is essentially scaling down to zero, so no billable metrics will be emitted from your application, and if your application, for example, use it during working hours at enterprise environments, it will be idle and it will be free during the night hours. What makes serverless, and another point about serverless, is that compute and storage is disconnected. So you can have your application on the storage, and it will be just a passive storage of your data. And compute can be easily switched. So it can be, your storage can be attached to many virtual machines or containers and deploy it and scale it in no time. With these serverless flavors come in the multiple revisions of your applications. And one of the typical scenarios nowadays that you provide, you will be supporting different revisions of your containerized application for different customers, or maybe providing preview of the new version of application to the selected customers in production. And for this, you can use multiple revisions of your application and direct different customers or different traffic towards needed version. Then serverless main benefit from my perspective is that you can start your product, your company, your fancy application without DevOps engineer, and just start easy and lean with deploying your microservices instantly on the Azure Container Apps. And this way you will save a budget on the infrastructure, you will save your budget on the security in production, and you will save a lot of money just for the start of your project. And serverless nowadays, and especially on Azure, that doesn't mean that you will not be able to move your application from the serverless platform. But we will discuss this slightly later on. The main challenge in overall serverless is understanding of how your application actually working, because a lot of things abstracted away from you. And from developer perspective, from engineer perspective, it's better to understand how it's really working and understand behavior, what can happen with your application in production. But there is a ways to mitigate this with load testing, with smoke testing, and some additional techniques, and we will talk about this as well. And one of the main factors to use serverless is that you should not have any complex networking setup. Because if you have complex networking, yes, Azure Container Apps now support advanced scenarios, network security groups, and etc. A lot of integrations, but some of this stuff will not be still available to you. So you need to the main factor for consideration to serverless on Azure is complexity of your network. Because if you have a complex network, then you need operations engineer, and this operation engineer needs to handle a lot of networking stuff in parallel. And last but not least, serverless is a perfect candidate for any workflows and any scheduled jobs. Yes, you can do workflows and scheduled jobs with help of Azure Functions. But if you have some advanced scenarios and you need to run different SDKs for your languages and and a lot of different versions of your services, Azure Container Apps is a good it's a good option to start with this. Let's talk briefly about the comfort zone. It's a very good chart, and it's actually what I'm just talking about. So there is a DevOps effort, and there is a control and ability to customize your solution. And for most of developers that is working in highly distributed teams, they just interested in doing work and staying in the comfort zone. So it's functions as a service and platform as a service. Here is the Heroku and Vexel, but it's just a screenshot. Container Apps fits right into this comfort zone. So it's easy to understand. It's easy to start with just Portal only, and it's easy to adopt infrastructure as a code via Bicep, and it's easy to deploy them from GitHub or from Azure DevOps. So it's about saving your time and abstracting a lot of things away. So all modern serverless built on Kubernetes. There is no magic in here. Yes, functions is built outside, but any containers that any serverless containers offerings in the cloud, they're built on Kubernetes. And my take on this, that in 5-10 years there will be need to use a full-fledged Kubernetes or even managed Kubernetes like Azure Kubernetes Service only in scenarios where you have super complex network, a lot of VPNs, a lot of express gateways, express routes, and etc., and some enterprise scenarios. But for most of the applications, there will be no point to use them. So if you're using serverless containers, essentially you don't need to hire a DevOps engineer. It's developer centric. It's fast time to market, and main thing that people are afraid of, it's a vendor lock. So it's like a common bias that if you use some serverless functions on Azure or Azure Container Apps, you will not be able to deploy your application on premises. And this is not true because myself, I done this several times. And it was connected to the products that have a lot of customers in the cloud. So customers in the cloud are using Azure Functions and Azure Container Apps. But some customers, because of the because of the legal limitations and etc., they cannot be in the cloud. And for these purposes, you can easily move your functions, Azure functions and Azure Container Apps to the on-premises for these customers, and this way expand the customer base of your product. And you will be keeping just a single version of the cloud application for anything else. And container apps on Azure, they are built around distributed application runtime and KEDA scaler. And this is the most powerful combo that I know, because Dapr and KEDA are used in many Kubernetes applications on different clouds and different environments. And because of this, Azure Container Apps are good choice to start, because you will not be locked in with the Azure Container Apps if you need to deploy your application on premises. But there is also some limitations to this, but we will cover this later on as well. So quickly about Azure landscape. When we're talking about Azure Container Apps, there is other services that allows you to deploy your application as containers. It's a classical app service with Docker support. It's Azure Functions with Docker support on premium and dedicated plans. It's Azure Service Fabric. Yes, it's kind of super legacy, but it's still alive, and some applications are still running there. It's container instances. It's not orchestrated containers, but at least you can run pairs of containers with this service for simple applications, like if you need SFTP and you need to deploy it quickly and efficiently, you can deploy it into container instances, and you don't need to configure revisions, integrations, and etc. It's just an image of your service, and it will be working. Then it's a container apps, and which will be like in a way pinnacle of the services of the serverless services on Azure. Then it's Azure Kubernetes service, obviously, and then it's a lot of clean Kubernetes installations on Edge or in the other cloud, or even on Azure. You have different flavors of Kubernetes services if you need to. And then we switch into the container apps. So as I said, KEDA, it's Kubernetes event-driven autoscaler. It includes a lot of different type of configurations for different type of autoscaling and scaling down to zero. So it's HTTP, it's RabbitMQ, it's Kafka, it's Azure Service Bus, it's whatever system you can use. Then it's a distributed application runtime. It built around it's Microsoft open source service, and it's built around. It's built for the purposes of abstracting configuration of the application away. So essentially, you as developer, you're just developing your service without the need of defining special database that you will be using, or special message broker, or secret storage. You're just using components like secrets database and publisher subscriber from the Dapr. And then at operations level, you can switch these components however you want, and you can have this different set of components deployed with different customers of your application. With Azure Container Apps, you don't have access to the Kubernetes APIs, and this is kind of it's actually good for you in a way. But when your application is growing, there's a lot of requests and comments on the Azure Container Apps GitHub to let people use different versions of the Dapr, different versions of the Dapr components, and call some sidecars from the configuration of your Azure Container Apps. Now it's not possible, and probably if you need this, then it's time to migrate to the Azure Kubernetes service. with Azure Container Apps, you have a lot of functionality, pre-warmed instances. Now it have session affinity if you need to have a large scale and keep your sessions sticky to the particular virtual machine or particular data. And it also have now rich compute options. Regarding Azure Container Apps configuration concepts, I will be super brief, but it's plans. It have two plans, consumption and dedicated. It have two types of environment, workload profiles and consumption profiles. It provides security boundaries around the jobs. It have containers, only Linux containers can be deployed on the Azure Container Apps. It have application revisions, sidecars, init containers for your database migrations and all sorts of stuff, and also have essentially cron jobs for scheduled execution of the tasks inside containers. It have revisions, immutable. All revisions are immutable. There is a list of all historic, not all, 100 historical revisions are available for you to refer or to reuse. And you can run multiple revisions concurrently, and this way you can have your blue-green deployment in a way. So you can run your jobs as a single unit of work, and they have a finite duration. So if you need infinite duration, you can use Azure durable functions for this and configure the state machine there. And yes, you have manual scheduled and event-based start triggers for the scheduled jobs. Regarding networks, all as Azure Container Apps essentially it's abstraction over Kubernetes, you have a network boundary. With each application, you will have the default VNet with default opened ports and connection types. But if you need a full VNet functionality like NSG, like VPNs, gateways, and etc., you need to deploy your separate configuration of the VNet with all the features and then attach it to the deployed Azure Container App. But it's a bit outside of this talk because it was covered in the previous version in two previous videos. So I would highly recommend to check them out as well. So regarding resiliency coming from the Dapr framework as well, but now it's also part of the Azure Container Apps. I will show it in a minute. So it's timeouts, retries, circuit breakers, and connection pools. And there is a concept of replicas, but essentially replica is just your instance of microservice or Kubernetes pod in the Kubernetes terms. Jobs also working with replicas, and Jobs was released last year, and they actively it was highly voted feature of Azure Container Apps, and I would recommend to use them along with your standard things. So if you need to validate some kind of a data or run a batch processing, it's a really good option because for this you can use quite powerful instances now. And before we switch to the Dapr, I will briefly switch to the Azure Container Apps. We have a concept of the environments. And here you can see environment on my screen. I have attached applications to my environment. And environment have this configuration of workload profiles. And here you're defining configuration of your compute. So it's two options here. It's consumption. In the region of Northern Europe, it's 4 virtual CPUs and 8 gigabytes of RAM. I also deployed a more powerful instance with 16 vCPU and scale from 0 to 3. Be aware that on dedicated for resiliency, you need to have at least 3 instances, and maximum scale is 20. And I cannot add any more, unfortunately. Yeah, but anyways, you can have up to 128 cores here and really huge machines to execute your computer vision or anything that you want to do. They might be limited. You might not be able to deploy a lot of instances, but they exist. And as I mentioned, container apps can actually powered by Dapr, but you can choose to work without Dapr really, and you can skip deployment of any distributed application runtime components for your applications. Now let's talk briefly about Dapr. Sorry, I used to click F5. Now it's slideshow. So essentially, Dapr abstract your dependencies away. I will show the code in a minute. So for each and every service that you have with Dapr, you have a sidecar that is connected to the Dapr orchestration service that is deciding what kind of components you should use. Not you, system should use to connect to external dependencies. And Dapr integrations for the Azure Container Apps are not fully compatible with the big Dapr on the Kubernetes, but team is keeping them up to date, and they actually provide a lot of great functionality. So what I'm using is service-to-service invocation. I'm not using state management in my apps because it's usually stateless. If you need state, it's more complicated scenarios. I'm using always pub sub, I'm using bindings, and I'm using observability and secrets. So this functionality covers really all the, like, I would say 85% of scenarios, because if something is missing and you need some external components on exotic components or exotic CADA scalars, you can always go with the Kubernetes. But also might take that in just a year or two, it will be almost full compatibility here. So regarding container apps, this is how it's working. So you have a container app. It's essentially the service. And each service that you deployed, if you enabled Dapr, you have a sidecar, and this sidecar connects to the Dapr component that knows configuration where you want to connect. And with Dapr functionality also comes this Azure Container App Services retry policies and resilience policies. So you can define configuration how your application would behave in case of the failure or some kind of internal issues between them. Resilience policies can be quite different, but for now, just a quick sample: HTTP retry policy and circuit breaker policy. Sorry for my stuttering. And another thing, Dapr for the container apps, it's actually using YAML manifests. Now they abstracted away with user interface. I will show it in a minute, but you can, if you deploy your cluster in automated way, your container apps, you need to deploy your YAML or a bicep file with a configuration of the Dapr sidecar. And there is a difference between manifests for Azure Container Apps and full Kubernetes. But it's not critical difference. And if you're already using Azure Container Apps with Dapr, it's super easy to migrate to Azure Kubernetes service, really. So if you if your application, if your company continue growing, then you should just lift your applications to the Kubernetes, hire DevOps engineers, and work there. So scenarios, but before scenarios, I will briefly show you configuration of the Dapr pub sub. So you can add Azure component here in the portal obviously it's better to be done with GitHub or Azure DevOps and Bicep infrastructure as code. But as you can see, its bindings configuration pops up secret and state. And you can define some additional values here. Pops up that is used at the moment have its custom Dapr component. I just explicitly mentioned the version of the component and name of the component, and added a connection string with secret to the service bus. So a message between services would be sent out. And this is the configuration of this Dapr component. But in order this component would be accessible to the application, I need to select a specific container app over here. And so this Dapr component pops up, will know which application can really access it. And from the application perspective, it's also Dapr configuration. It needs to be enabled. You have to provide the name and you have to provide the configuration here. And with this being said, let's have a look at the sample application. And these sample applications, they are available through the GitHub repositories. Sorry, quick answer to the question. Azure Functions can be also deployed to the Kubernetes. And actually, if you use Azure Functions with SCADA scalers, they can be deployed on any on-premise Kubernetes cluster or any cloud. So like Microsoft is caring about you. So there is no vendor lock with serverless really. And you can just continue developing your Azure Functions without any hassle. And if you need to deploy them on-premise, you just packing them into the container. Azure Functions client really doing this quick and effortless way, and you can just drop this container to your on-premises Kubernetes for the compliant customer, and everything would be just fine. Okay, so moving further with this, I have this repository on the GitHub, so you can do this step by step by yourself. It have infrastructure as code and so on and so forth. So application there, it's actually with two services. It's service T-Paper delivery and T-Paper orders. I'm publishing these services for the sake for the easy demo from the Visual Studio, and in a way, even with new Microsoft Aspire that Microsoft will release probably this year, I hope so, you will get the same seamless experience of developing things. So it's like you developing, debugging distributed services locally and then deploying them to cloud, to container apps or Kubernetes. But back to my app. So it's order controller. And for first version of services for container apps without Dapr, I'm just using database and direct HTTP calls to the services. I'm using just environment variable delivery URL, put in HTTP request, and sorry, I type it in something here, and just sending this request from the T-Paper orders to the delivery controller. So you can order something, and then it will trigger the delivery. And here it's just HTTP. I'm using HTTP GET. Sorry for this. It's not post, but here you go. So I'm using HTTP GET here, and it's just HTTP method. It's how you can use Azure Container Apps with HTTP without any Dapr, any event-driven stuff, and etc. But the next version, I will just show you the structure of repository that you will get on the GitHub. So you have a local containers, you have infra, you have container apps, and you have container apps Dapr. If I will switch to the Visual Studio with Dapr included, the difference is the first difference. It's actually update the Docker Compose. So in Docker Compose, you don't have you have not only particular version of the service, you also have a Dapr sidecar for each service. It's a lot of details there, but these details on the GitHub. So here, the sidecar is directed towards tpaper service, and then it's tpaper orders, its delivery service, its order service. And the second sidecar is directed to the tpaper. You can run this application locally if you install the secrets from output of the infrastructure of the Azure CLI. But this is the difference with previous Visual Studio. And another difference, quite important one, that I'm not using anymore any HTTP post or get request. So I'm just injecting Dapr client. It's injected at the startup, I think. Yes, here on the controllers at Dapr. And if I switch back to the controller, I created a new, sorry, it's delivery. I need to order, yeah, like this. And I'm creating the order, and then I send in create delivery for order. But create delivery for order is just calling Dapr client, publish event async, and I'm using the name of the pub/sub service and additional method for this service. It can be different. It's a lot of different constructors here, but we have a limited amount of time. But you can experiment with the stuff by yourself because all code is there. So this is the difference. Not any HTTP requests, just calling the Dapr client and Dapr pub/sub component. And if you will be switching Dapr configuration in the production or on the staging environment, it can be on staging. One of the cases that I use it really, it's on staging. We have not Kafka, we have RabbitMQ because it was cheap and don't need to have some complex configuration. But in production, we use it actually Kafka. But for these purposes of a pub/sub, it was not important to test with the Kafka in the staging environment. And this way also, instead of if you use like for the pub/sub an integration or end-to-end testing proposes RabbitMQ, it will be as good as Kafka for these scenarios. So I replaced all the HTTP calls with just Dapr client. And the same goes for the delivery. In the delivery, I just annotated that pub/sub component with create delivery queue is used here. So this is a brief overview of the code, and we're switching back to the presentation. Let me quickly do this for you. Okay. Okay, and container apps. About scenarios. My bad, with a 5. Yes, scenarios. So what about scenarios where you can use Azure Container Apps? First, it's a legacy solution migrations. You cannot containerize anything and every solutions because they can be some kind of a COBOL mainframe and etc. on the old legacy system. But still, a lot of .NET applications built for .NET 4 and especially some legacy APIs, even if you will create a wrapper for the ISPX applications or VCF services, they can be containerized and put as is to the Azure Container Apps. But when I say in legacy applications, it's usually Azure App Service, because App Service is evolving still, and they have containers and etc. And they have a new serverless scaler now in production, but still container apps provide a better portability and evolution for your apps. Then you can have some existing app services or Kubernetes or mix of different even clouds. And if you want to try a microservices approach and work with revisions, work with different blue-green deployment and etc. For your containers, you can actually use Dapr for your old applications. Dapr actually can work on premises as well. And you can use a new service with Dapr configuration on your container apps. And this way you can start to modernize your application step by step. So most volatile code from your application can be really converted to the container and put to the Azure Container Apps, and then you can use Dapr as a glue or use even Azure Functions as a glue. And Azure Functions also have now support for the Dapr in and out triggers, so you can use them with Dapr applications at will, or connect your Azure Container Apps with functions to something else. Then it's the part I'm being criticized a lot, it's downgrade from Kubernetes or Azure Kubernetes service. Why would I recommend this? Over the years, I've done many technical audits of the companies, like identifying bottlenecks, problems with current solutions, or helping the teams to resolve modernization problem. And what I've seen, a lot of companies, even now in production, they're running on the standard configuration of the AKS. They are not patching the AKS. They have a standard 3 virtual machine scale set behind the Kubernetes, auto scale disabled, and they just running Kubernetes as like a static containers, I would say. And if something if they don't have enough resources and etc., they just they draining the nodes of Kubernetes and creating the new nodes with more powerful configuration. So no scale, no any feature of Kubernetes is used. And if this is your case, then you should definitely pilot Azure Container Apps and try to figure out if serverless tier of Azure Container Apps would be enough for you. And if you're talking about serverless tier, it's compute for consumption tier. It's the same as for, let's say, Azure functions in your region. So it's usually it's up to 4 virtual processors and up to 8 gigabytes of RAM per instance. If you need more, you can use dedicated, but dedicated is more complicated in a way. And to run your system cheaply, I mean, the cheaper than Azure Kubernetes service, it's definitely a consumption tier of Azure Container Apps. Then if you're trying to pilot microservices and you know that your company will grow or your company will be acquired by bigger company, bigger enterprise, you will be also safe and sound with Azure Container Apps. Why? Because it's if you leveraging Dapr on the container apps, it's super portable like this. If you're not leveraging, adding Dapr components and abstracting your database away or some other stuff, it's also quite easy. And lift your containers to the Kubernetes platform, even on premises, it will be relatively easy task, and you can do it. Another thing, it's about jobs. Usually, if you have a super simple jobs, it's Azure Functions is enough with schedule trigger, and you don't need a lot of memory and etc. But if you have jobs that is processing some kind of PDF files, or these batch jobs using some kind of computer vision on the Azure cognitive services to identify some risky behaviors and so on and so forth, you will not be able to get away with Azure Function alone. And if you have some specific memory requirements, like you need 64 gigabytes of RAM and etc., you need to use Azure Container Apps as well, because it will be more robust and more predictable, and you can deploy more powerful compute here. Yes, on dedicated Azure Functions, you can deploy some powerful configuration as well, but it will not be the same as Azure Container Apps still. And yes, lift in Azure Function Applications. It's something that I also done. I did it maybe 3 years ago or something like this. We lifted. We have a customer on premises, and the only way to work with this customer is to move our serverless application to the on-premise and process all the data on the data in the data center of this customer. It was a huge success. And the same goes actually with Azure Container Apps, because if you have advanced networking and you don't really know where your solution will land in the future, you can containerize them and put to the container apps with network perimeter and etc. And then you can easily port them to the Kubernetes on premises. Switch to serverless containers. So it's a bit of a duplicate. Sorry for this, I missed this. But here is the new point: the CPU-heavy Azure functions. So CPU-heavy Azure functions really, if you need to calculate something or work with the GIS data, they are not the best service to use for this kind of purposes. And as I mentioned, with Azure Container Apps, you can spin up to 128 CPU machine and have a horizontal scale for this kind of machine. And if you need to process a lot of GIS data or something CPU heavy, I will not mention other heavy CPU heavy operations, you can do this. And also on container apps, you now have GPU powered instances, and with this you can do some inference and other type of activities that is probably requested. You can do your own SaaS for your company if you need to do some inference or any other ML activities, but it's still in the preview. Also containerizing apps from the old data centers, so some kind of internal portals or internal banking application that was written 20 years ago. It's if it's something like a .NET 3 or 3.5, it can be containerized and put to the Azure Container Apps. And if you have it's not exotic scenario, but it's just a scenario if you use a Taglins, Azure Container Apps, and they have support for the actors, and actors provided through the Dapr framework. And you can use these actors also on Kubernetes later on. But word of the warning here that these actors, they have a less functionality than Aglins, because Aglins is still growing, still evolving, and team at Microsoft are building Aglins as a good product, a really good product. So actors on Dapr have less functionality than on Aglins. So as I mentioned, you can complement existing application with Azure Container Apps. And one of the scenarios here, if you have a Azure Service Fabric deployed somewhere and it's still working and it's using containers, you can use containers from the Azure Service Fabric and containers that is changed often, and just put them to the Azure Container Apps. But the main problem here is that Azure Container Apps do not support Windows containers. And a lot of containers on the Azure Service Fabric really Windows containers. And this is kind of limitation that you should know about. Complex network scenarios I already covered. And also, Azure Container Apps can serve if you already have Kubernetes and don't want to switch away from it. You can use Container Apps as a cheap dev stage environments, and have just alternative pipelines for the dev environment, and have multiple dev environments on the consumption level on the consumption plan of the Azure Container Apps. And I done this for developers because there were no resources to support several dev environments from the operations, and Azure Container Apps can be easily supported by developers themselves, and this way they can have multiple environments for different teams for integration testing and etc. New project evolution. Just want to mention from the if you start building your own startup or your own project, there is a Microsoft helping you with this really, because there is a quite logical evolution path. So you're starting with the serverless functions, and they have input-output triggers, easy model, and you're starting with some kind of simple database. Then you can switch to container instances probably, but it's not recommended. Then it's container apps. Then if complexity starts to build up, you have a lot of integrations, you have a lot of networking, and you have some distributed challenges, let's say. So you hire a DevOps engineer, and DevOps engineer just adding the Dapr, configuring some components and learning about it. Then it's migrated to the Kubernetes, Azure Kubernetes service that you can use with more advanced scenarios. Then it's easy to migrate if you have Dapr already on your cluster and Dapr configuration for your application. Your developers don't need to change anything inside. And this way, you can easily lift your application to the on-premise for the particular customer and make even more money. And this way, also, if in the future you will need to have more containers or more versions of your applications, it's also easy to deploy just a new Azure Container Apps environments and even deploy these environments at customer subscriptions. So just briefly about decisions. If you need to make some kind of decision making, you go into the Azure Kubernetes service if you have a really high load and complex network, because you need this manual configuration, and you have a DevOps engineer that is working with your solution. If you need to process really huge files and complex workloads, it's probably Azure Kubernetes Service. It's also better alternative. But with introduction of the GPU instances now in preview on Azure Container Apps, it might be not true anymore, but it's better to wait general availability. So if you're running some kind of AI workloads, then you can consider container apps also. Actually, you have serverless containers in the Azure ML Studio, so it's probably moving in that direction as well. So if you know behavior of your application and how many memory it will consume, then consumption tier of Azure Container Apps is really cool, because 4 vCPU and 8 gigabytes of RAM, it's more than enough for any service. And usually on Kubernetes configuration for the particular nodes and pods, it's less than this value. Azure Container Apps is super effective and effective cost-wise with burstable scale. And Azure Container Apps with Dapr essentially mean that you can move your application anywhere. You will have this Dapr abstraction open application model, so called, and your developers can already leverage this open application model and develop functionality without thinking about dependencies. And you can switch dependencies at will when you move your application. Another thing, you need always to do the load smoke test of your serverless services, because you don't know what's going on inside. So you need to know behavior of your application under the heavy load and what can happen there. So about cloud app evolution, you're starting on the left with functions as service. Then you go into the web app, static web app, serverless containers. Then if something is not enough, you switch into the full Kubernetes, to the managed Kubernetes like AKS, and then you can switch to the on-premises or to the local clouds. Why would you switch from Kubernetes to Azure Container Apps? Just to re-emphasize, small customers don't really have any expertise and operations capacity to update or or to update or maintain Kubernetes. No devs, no security guys, and so on and so forth. So it's better to delegate this complexity to the cloud until the moment when you have a DevOps engineer. Container apps can also run different flows or flow scenarios for you. So if you use Kubernetes just to have a long-running workflows with a lot of memory, now with dedicated plan of Azure Container Apps, you can do this with Container Apps. You having multiple revisions, so you can dedicate different revisions of your application for different customers. So if you have like 3-4 revisions available for different services or combination of services, you can do this easily with Azure Container Apps. And you have a GPU plans and a lot of dedicated compute. Another obstacle is that just developer start getting be comfortable with Kubernetes. And so if you will suggest to developers to use Kubernetes, they great and they feeling great and they on board with this usually. I mean, these kind of principal engineers. But when you will try to consider when you're trying to offer Azure Container Apps, it's usually the main thing that people talking about is like, oh, you have a vendor lock, you will not be able to lift your application from the serverless containers to anything else, and it's a problematic, and so on and so forth. And you need to rewrite the configurations and etc. But it's not true with Azure Container Apps, and you can really use Dapr from the day one to avoid any configuration changes and just adjust the manifest. So limitations briefly. Windows container support, it's actively discussed now in the issues on the GitHub. It might happen, might not. Windows container support existing on the Azure App Service. Some scale rules and managed identity connections in the preview, and not all scalers available from the KEDA list of scalers. Some issues like bring your own registry, and from developer side, the main issue is that people not always understand how services scaled. What kind of application components result in the unpredictable behavior. But it's about developers need to learn how their application works. I mean, is it memory heavy, is it CPU heavy, or is it just a crude application and something is fishy going on with additional components like NuGet packages and so on and so forth. So if you have a memory intensive application, you cannot you can deploy it on the consumption plan, but it will end up badly for you because it will be just it will be a lot of issues there. And about managed Dapr sidecars, there is a list of the sidecars on the main Dapr repository and list of those sidecars that are available with Azure Container Apps. And they are not really matching between each other. So sometimes you need to wait for the update of the particular component. But still, the Azure Container Apps have good amount of the Dapr components and good velocity of updates. And if you need something super exotic or custom, yes, you need to go to the Azure Kubernetes service, obviously. And yes, this is people continue asking again and again. Can we have some kind of access to the Kubernetes API from the Dapr, from Azure Container Apps? Can we access it? Can we do something about this? No. If you need Kubernetes APIs, if you need customized KEDA scalers and some extra features, you should use Azure Kubernetes Service. Future of Azure Container Apps. So there is a roadmap on the GitHub, and on the GitHub you can actually track what's going on. So now in progress development, they have a lot of quite neat features like import of the certificate from the key vault. Yes, you can connect key vault to the secret component of the Dapr, but you will not be able to import the key vault, import certificate from there to use it at your host. Dapr resiliency in the public preview. I will show it briefly to you now. And yes, before thank you, I will just show this briefly to you. So here is a pub/sub component on the root Dapr on the root container apps environment, and here you can add resiliency. Inbound and outbound, you cannot add. They don't have in UI these circuit breakers and etc. But timeouts and HTTP retries can be set up right now, and it's a part of the Dapr framework. But you can deploy your circuit breakers with Azure Bicep or with Azure CLI. And if I will touch briefly on the observability and ingress, you have a lot of configuration here from the portal, but obviously you will not be using this from the portal in your production environment. But for the sake of experimentation, I would highly recommend to use GitHub and use a simple version of application to connect them, to deploy them to the Azure Container Apps, and to check how they're working. One hint, there is a service connections preview, and all service connections here are connected to the My database for this application. So you can use, you should use the service connectors, Dapr configuration, and then you can deploy your resources at will. Just to show that application is working, here is the application creating new orders, and here is the application creating new deliveries. It will be with time because they are using the Azure Service Bus, and there is a delay. So each application, essentially, each container app application is your service, and there is almost no time left for the questions, but I would highly recommend to use this GitHub repository to run and deploy your own Azure Container Apps. I would highly recommend, if you have any questions about this short talk, you can connect with me on LinkedIn, Twitter, or GitHub, and just ping me and ask, like, I cannot deploy this, why it doesn't work, and I will gladly help you. And it's 3 minutes left. I actually didn't have opportunity to cover everything that I wanted, but just to briefly show the evolution from the perspective of the YAML manifest. So here you can see it's a YAML manifest for the Azure Container Apps. So it's a pub/sub Azure Service Bus. It's a Dapr component manifest, but it's super easy and super simple, and it's abstracted away in the UI. As I showed you before, here it is configured as just values. And if I will switch back to the Notepad, then if we will need to migrate our services from the Azure Container Apps to the AKS, it's slightly different manifest, but it still have it already have scopes. It have a secret store, but in a way it's the same pub/sub, and it can have the same name. Then it's a pub/sub with service bus. Then with the same pub/sub name, to avoid changes inside code of your application, you can have the same name here, and can configure this pub/sub for the RabbitMQ. And then you just need to deploy RabbitMQ to your Kubernetes cluster, and your application will work flawlessly. So if you will be lifting your application and installing it for different customers on Azure or on premises, what you need to change with the Azure Container Apps and Dapr, it's just manifest, because it will work flawlessly in most of the scenarios where you can use a Dapr configuration. With that being said, I highly recommend to pilot and use Azure Container Apps, be aware about workload profiles, and that you can have a dedicated compute that is cost a lot. Actually, here I can just finish with the demo. Here is the costs for the not in Europe, but as you can see, it's quite huge instances, even with GPU and CPU available there. Thank you for joining me this evening, and I hope there will be more people that using Azure Container Apps in production and less people using Kubernetes when it's not needed.